Today we're going to be talking about special parts of similar triangles. So we're going to head over here to the book and take a look at some examples. The very first thing I want you to notice is it says, if two triangles are similar, then the lengths of the corresponding, I'm just going to highlight the word altitudes, are proportional to the corresponding sides. So right now, I'm going to use two colors right here. I'm going to use blue and green. First thing I'm going to do is I'm going to color in my altitudes in blue. So this is the altitude of this triangle right here, and this is the altitude of this triangle. Now, what I'm going to do is I'm going to label, this is my big triangle and this is my small triangle. So a lot of times what I'll do is I'll label which one am I comparing. I'm comparing the big to the small. The book is set up a proportion like this. And that, by the way, this proportion is totally okay to set it up like this. I do things a little bit differently. I like to compare the big triangle to the small triangle. So what's my segment for my altitude in the big triangle? That segment is AD. And what's the segment in my small triangle for the altitude? FJ. So I like to do it side by side. Now, over here, it gives us some corresponding sides. So the sides that they use in the book are the distance from A to B, which corresponds to the distance of F to G. So what I'm going to do down here is I'm going to write A to B and F to G, and I'm going to set up my proportion this way. So how did I set up my proportion? I said I compared one altitude to the other altitude. And then I compared one corresponding side to the other corresponding side. What did they do that's a little bit differently? They did altitude over altitude equals. See how I did mine side by side. They did theirs vertically. So either way is okay, but you got to make sure that you know what you're comparing. So notice, what do I always do? I always compare big to small. And that's how I set it up. And remember, what are the blue segments right here? What are those called? Altitudes. By the way, what does that mean? Altitude basically means the height, right? Altitude. I'll erase. So, it says, if two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. So that's what this is talking about. Okay? Just remember, just because the book used A to B, you could have also compared what? A to C to what? F to H. Or you could have used B to C and compared it to H to G. So just because the book used this side doesn't mean that's the only corresponding side. Okay? You can use whichever sides you can or allowed to compare. Now we're going to go down to 7-9. Okay? We're going to take a look at that. This one's a little bit different. It says if two triangles are similar, then the lengths of the corresponding angle bisectors. What is an angle bisector? It's a segment that takes an angle and cuts it perfectly in half. I heard somebody say in half. Then you can compare that angle bisector to the corresponding side. Now, these are not altitudes, everybody, but this right here, L to P, is an angle bisector, and R to T is also an angle bisector. So, yes, sir. What I want you guys to compare is we're going to compare this time, instead of big to small, we're going to go small to big. Small triangle to big triangle. What is the length? What's the distance of the angle bisector in the small triangle up here? Which one's the small? Okay, I'm talking about the angle bisector. What's the distance of my angle bisector in this triangle right here? L to P. What's the angle bisector in the large triangle? R to T. Okay. Now, they use, this is their corresponding side from here to here. And you'll notice that LM is proportional to R to S. So right now I'm going to write LM is proportional to R to S. So what I want you guys to have in your journal is I want you guys to have pictures. I want you to make sure you understand that this is not an altitude. How do I know that this is not an altitude, but it is an angle bisector? What does an altitude have to have that this does not?
A right angle.
Correct. It has to have a right angle, and this does not have a right angle. What does this do? It bisects whatever this angle is into two equal parts. And once again, you'll notice, how did I set it up a little bit differently? I set it up side to side. How did they set theirs up? Not side to side, but top to bottom. Okay? So I just want to make sure you understand both ways can work. You just need to know which sides you're comparing. So you could set it up this way, or you could set it up this way. I like this way because I like comparing small to big. All right. So just because we are using these sides to compare, these are not the only two sides you can compare. You could also compare KL to QR, and you could also compare, if you wanted to, the distance from K to M, which is this distance, all the way to Q to S. So you could also use those other two sides if you have the angle bisector. So you could compare blue to blue to green, or blue to blue to purple, or blue to blue to red. It doesn't matter which ones you use as long as you're using the same corresponding side. So remember that. All right, here we go, moving down. 710 is the last one we're doing on this page. We only have two more to do. What's different about 7.10? It says that two triangles are similar in the length of the corresponding medians. Now, a median does not split an angle in half. A median splits a side in half. These are the medians. They don't split the angles in half. They split the sides in half. How do I know they split the sides in half? Because you see this tick mark here and this tick mark here. What does that let us know? They're congruent. Just like this tick mark and this tick mark. Lets you know that these have been split perfectly in half. So right here, you can draw the triangles and label that. This is what's called a median. So right now, I'm going to call this triangle the big triangle. I'm going to call this the small. So this time, I'm going to compare big to small. So what is the length of my median in the big triangle? What's that length? DC or CD. What about the small triangle? ZY or YZ. Okay? So this median compared to this median, these are comparable. Now I'm going to go over here and I'm going to highlight the other side. Now they compared CD to YZ vertically. I compared them horizontally. Now we're going to compare AB to WX. AB is this all the way across. WX is all the way across. So right here I'm going to write AB on the bottom, and over here I'm going to write WX also on the bottom. Yes, you can set them up this way, or you can set them up this way. Either way is okay. And once again, these aren't the only corresponding sides. What is BC? Which side does that correspond with? XY. Right here. And what does A to C correspond with? WY. Thank you for not saying DC. I appreciate it. Instead of AC, DC. All right, anyway. So, going back. Right now, all I want in your journal is what? Blue to blue, green to green. That's what I'm looking for in your journal. Blue to blue, and green to green. All right, quickly turn the page to 504. because this one might be the trickiest, but it's definitely pretty cool. So right now, I'm going to zoom in as much as I possibly can. We're going to slide over. Look at this picture right here. You guys see how this is red, and this is red, and then this is blue, and this is blue? It's going to be very important that you guys draw it in exactly as they have drawn it. So right here, put a blue segment to a blue segment, and a red segment to a red segment. Yes, absolutely. Now, understand that this right here, M to J, this is very important that you understand what M to J does. If it doesn't do this, then you can't use this method. Do you see how MJ, what does that do to this angle right in here? J to M, or M to J, is what? It's an angle bisector, which means it cuts this angle right here. I'm going to put a little tick mark and a tick mark. It cuts it perfectly in half. So make sure you understand that the distance from J to M is an angle bisector. So get this in your journal as quickly as you can. If you need to pause the video, pause it now and put all of this information in your journal. Now, something you need to be paying attention to, it says an angle bisector of a triangle divides the opposite side, which is this right here. This is the opposite side proportionately. Okay? So right now, I want you guys over here, I want you to understand, you can set this up as J to K. The proportion from J to K over M to K will still be the same proportion, or the same ratio, as from J to L to M to L. So this right here, this is another way you could set it up. I just think big side to small side is going to be the same ratio as big side to small side. It's very, very easy to set up. Big to small, big to small. I always try to set up my ratios big to small, or small to big, right? As far as how I'm organizing it. So right now, what I'd like us to do is I'd like us to look at our assignment right here. So let's go ahead and zoom in. Number 20. Does it ask us for the scale factor? No. Does it ask us to really do anything except solve for x? No, it just says find x, okay? And if you were a smart aleck, you'd put a little arrow here and say, there it is. Found it. Found x. No, you won't get credit for that, all right? So I probably should go back, instead of saying find x, I probably should say solve for x. So I'll go back and do solve for x. But now, what do you guys think, when I color this in, what do you think I'm coloring in? This is not a quadrilateral. We're dealing with similar triangles. Okay? Similar triangles. But right now, it's in 7.5. It's in your similarity and triangles packet. All right? It's on problem number 20. It's on the third page, I believe. You don't have to put this in your journal. Right now, you can just look at problem number 20. And I want you guys to understand, what am I saying that this is right here and this is right here. Look at this picture. It's what? That's correct. It is a median. Very good there, Colin. Median. I'm going to label it. Now you are now immortalized in YouTube history getting this problem right. All right? Go back and say, look, I was right. You didn't even give me the answer. That is a median, and that's a median. How do I know it's a median? Because it breaks H to L and X to Z in half. So we're going to compare the blue to the blue, and then we're also going to compare the green to the green. Now, if you look carefully, these pictures basically set up the proportion for you. How about this? I'll put a box equals a box over a box equals a box. It just sets it up. Go ahead. Set it up for me, Alex.
10 over x.
Close.
All right. 18.
10 over 18. There we go. Equals.
X.
See how easy that is? It's like the picture sets up your proportion. 10 over 18 equals x over 15. Now all you have to do is what? Cross multiply and solve for x. Okay? So right now, on your own, why don't you guys do a little cross multiplication, solve for x. I'm not going to give you the answer, okay? But it's going to be 18 times x equals 10 times 15, which is 150. If you can finish solving for x, you'll get the right answer for problem number 20. I'm not going to tell you. All right. Number 21. What do you think this green line is called? This green segment. What do you think that does?
Bisector.
That's right. This is an angle bisector. Okay? And we just wrote notes on what this angle bisector does. Now here's how I'm going to color it. I'm going to color it red, and then blue, and blue. So right now, watch what I do right here. This basically, think of this as the fraction bar that sets everything up perfectly for you. So, think you can handle it, Jacob? Setting up this proportion? Go ahead. Oh, go ahead. Sorry. Mr. Shields, go ahead.
20 over 7.
20 over 7 equals
24 over x.
That's it. You guys see how this basically sets up the proportion right for you. If you know this is an angle bisector. I'm not going to finish solving this. That's how you set it up. You guys can solve the proportion on your own. The last problem that we're going to do together, that's on this video, is problem number 22. So I need you guys to put problem 22 in your journal. Write it exactly as it appears. This is your last problem of the day. Okay, problem number 22. There is a great way to be able to find perimeters dealing with similar triangles. Let's show you this way. It's pretty cool. So what I want you to do is we are going to trace one triangle all in blue. So this triangle is going to be traced in blue. And this triangle right here, F to D to E, is similar. So this triangle right here is similar to triangle B to C to D. And so this triangle right here is B to C to D, right there. So this blue triangle is similar to this red triangle. Blue to red. You can kind of see the blue triangle is smaller than the red triangle. Okay? Now, we're going to try to find the perimeter of BCD. First, I want you to find the perimeter of triangle FDE. What is the perimeter equal to? 4 plus 5 plus 8. That's 17 what? 17 units. Okay? So what I want you guys to understand is you can actually take the perimeter of one triangle and compare it to the perimeter of another triangle. Just like you can compare the side of one triangle and compare it to the side of another triangle. This is very, very, very important that you guys have this in your journal, because this makes this problem ridiculously easy. You can compare perimeters to each other, just like you can compare sides to each other. So watch what we're going to do here. Okay? What was the perimeter of the blue triangle? 17. What's the perimeter of the red triangle that we're trying to find? We don't know, so let's put P. Now, which sides do you think we're going to compare? We're going to compare this side right here, which is what? 8. And what are we going to compare this side to in the other triangle? What do we compare the 8 to in the red triangle? You guys see how you see how you can compare this side to this side. So we're going to put 12 right here. And guess what? Now we have our proportion. So when we cross multiply and solve for P, guess what we didn't have to find? We didn't have to find this side or this side to add them all up. All we did was find the what? found the perimeter of the blue, and compared them. So here we go. Before you guys leave, but 8p equals 17 times 12. And when you divide both sides by 8, what is 17 times 12 divided by 8? I'm sure somebody in the class did it. Nobody? Nobody in the class has done it yet? No. Are you kidding?
What did you say? 17 times 12.
The perimeter, all right, the perimeter of the red triangle right here, this perimeter is equal to 25.5 units, which is your answer to problem number 22. Y'all have a good day.